All right, I'm back with Chapter 19, Questions for Study and Discussion. So, can you answer these? What are some of the specific advantages of GMAW? Well, some of the advantages of GMAW that it produces high-quality welds on a variety of ferrous and non-ferrous metals. Okay, one, it can be done at low cost. We can use a wide range of material thicknesses, higher deposition rates, faster travel speeds, less electrode waste, and it's easier to use than manual processes like stick or TIG. Okay, there's not very much post-weld cleaning because everything's slag-free, and we can really use it for like mechanized and robotic applications without too much. Okay, so why is DCEP current used? Because it's the most efficient current. It produces deep penetration and helps with surface cleaning. What results can happen if we use DCEN? Well, DCEN shouldn't be used because it doesn't have very good penetration. It's very shallow, it's really wide, and it makes a lot of spatter. There's no surface cleaning, and it's a mess, okay? And it makes it really globby and nasty, okay? So how does CV and CC differ? Well, CC welding machines have a steep bulk amp curve, and CV welding machines have a slight sloping. Remember when we talked about that in the beginning? The slope is really kind of gentle. Okay. So what is the advantage of using a CV machine? Well, it provides the energy necessary to melt the wire. All right, what are the elements that make up air? Okay, so air is made up of 21% oxygen, 78% nitrogen, 0.94% argon, and 0.04% of other gases like carbon dioxide. So why is oxygen harmful when we weld? Well, just because we breathe it doesn't make it, good. So oxygen is really reactive and it combines with other elements in our weld, okay? And it forms oxides and gases. And if the deoxidizers didn't, take it out, the oxygen, it combines with our metal and it can cause porosity. And ultimately that porosity, those little holes that are coming out, are actually the gases coming out before the material solidifies. Okay. All right, so let me see. What does nitrogen cause the most serious problems? Well, kind of the same thing. It gets into our molten weld pool, okay? It forms nitrides when it cools. And here's the thing. It increases hardness, decreases ductility, and decreases impact resistance. And of course, when we have a whole lot, it can cause porosity. So this means nitrogen and oxygen are trying to get out of your weld before it solidifies. That's not good, okay? All right, so when is argon or an argon mixture considered the ideal gas? So straight argon is not used as a shielding gas except for aluminum, copper, nickel, and titanium. Oxygen is added to argon when we weld mild steel to improve bead contour and penetration. All right, so when is CO2 better then? Well, CO2 is considered an inert gas when we're at normal temperatures, but when it gets to high temperatures, the CO2 dissociates into carbon monoxide and oxygen. I know, science here. Okay, because of the oxidizing characteristics of CO2 and the welding wire used with CO2 must contain deoxidizing elements, okay? The deoxidizing elements combine with the oxygen and prevent it from causing porosity and other problems in the weld. I hope you got that. Okay, so how is it possible to determine the proper gas flow? Well, for the majority of what we do, it's between 20 and 35 CFH. When we use a WPS or welding procedure specification, it tells us specifically, okay? But most of the time, final adjustments, they need to be made kind of on a trial and error. We have to find out what's going on. All right, what happens if the gas flow is allowed to drift from the welding area? Well, gas drift can occur with high speeds, drafty conditions, and things like that. And ultimately, we get inadequate gas shielding. So what does our weld look like? Well, we may have a lot of porosity, a lot of pinholes, or it just may look like bubble gum. So it's not melting right. Things aren't right, okay? What factors must be taken in consideration when we select the correct diameter welding wire? Well, we know that wire comes in 0.023 to 1/16 of an inch. So we choose materials in according to what? Thickness of material. Then we also want to take into account for strength of material. But we also need to keep in mind that position is a factor. And like for vertical and overhead welding, a smaller diameter wire is preferred, especially if we're doing overhead because it makes a smaller pool and it's easier to handle. Okay. All right, so let me see here. So how is the wire fed to the welding gun? This is the official one. A wire feeder automatically advances the welding wire from the wire spool through the welding gun cable liner and welding gun to the arc. So what determines the rate at which wire feed should be set? Wire feed speed is measured in inches per minute. Wire feeders usually can be adjusted from 70 to 800 IPM, and usually the welding specification gives us the wire feed speed as well as the voltage for specific welding wire and shielding gases. So why is correct electrode extension important? Well, remember we were talking about autocorrect? So we don't want it too hot or too cold because ultimately we don't get a good weld. So we want to make sure that it stays the same throughout. And we don't want more probably than 1/4 of an inch. Otherwise we won't even get any good gas coverage. All right guys, as always, take care.